with like just 2 or 3 answers, and we're going to go over it. So make sure that you're copying this down and getting your assignment completed. Because again, you want to get every grade that you can get in, so you keep your grade up and you're ready to go for the end of the year.
Yeah. Can I take thing for the library? Because it's not very on this card. It's like all the way.
Yeah, go ahead.
Oh, he done broke it.
All right, so let's take a look. I've assigned the reading, and I've assigned the actual assignment itself, so you should see both of them in there. If you click on the reading, we're going to use just a couple little parts of this to help us answer the questions. And if you click on the assignment, let's take a look and see. I am recording. Let's take a look and see what the question's asking us for. We got one question, so let's go ahead and read through it and see what they got. The mineral quartz is much harder than clay minerals. And actually, if we come over here, I can show you exactly how. Quartz on the Mohs hardness scale is about a 7. So it's harder than a knife. It's harder than glass. It's harder than a nail or a copper penny. It's harder than all sorts of stuff. There's only a couple minerals that are harder than quartz. And so quartz is pretty high up there. It's a hard, pretty solid mineral. What do we use quartz for? Quartz goes into a lot of countertops. And that's because if I drop a big heavy pan on my countertop, I don't want it to just shatter and break. They're usually pretty expensive. So you want to use minerals that are pretty tough. And, you know, if I slice through a banana or something, my countertop's not going to have a big scratch in it. It's going to be fine. Now, biotite and muscovite, which are called micas, they're going to be down here like in between 2 and 3. They're pretty soft. In fact, most of the time, they're about the hardness of your fingernail. And so that's pretty soft for a mineral or a rock. That's going to be one of the softer ones. So when we go back to the problem, they confirm quartz is much harder than your clay minerals such as mica, though both quartz and mica have some similar chemical properties. So 1, identify the chemical class that both quartz and mica belong to. If you go to the reading, and we scroll down to our little chart here, just below right here. We can see in the examples that quartz and mica are on this same row right here. So quartz and mica are part of the group called silicates. So that's going to be your first part of your answer. Quartz and mica are both part of the groups called silicates. And then number 2, describe the basic chemical unit that is shared by both quartz and mica. Be sure to identify the shape and composition. That's what we went over just the other day. And so that is going to be right up here. Silicates are all silicon and oxygen bound together in a pyramid-shaped tetrahedron. Did they not give you the formula right here? Is it further up? Silicate tetrahedron. I guess it's not. They should give you the formula right here. Well, there it is. Let's just click on this. Can I do that? Yeah. Open a new tab. So this is what silicates are made out of. They're made out of this SiO4 molecule. What shape is this? It's like a pyramid shape. Yeah, it's not a 4-sided pyramid. It's just a 3-sided pyramid, but it's still a pyramid all the same. And so this is your molecule. The formula for this molecule is what? How many silicons do I have? 1. And how many oxygens do I have? 4. So how do I write that in like an actual formula? SiO4. Yes, I got 1 silicon and 4 oxygens. It's SiO4 is my chemical formula. So does that answer everything for that one? Describe the basic chemical unit that is shared by both quartz and mica. That's your SiO4. Be sure to identify the shape and the composition. And so you've kind of done that. As long as you tell me it's SiO4 and it's shaped like a pyramid, you could even say 3-sided pyramid, that's going to be good there. And then the last one, how does the chemical structure of quartz and mica affect the relative hardness of each mineral? And that's actually in the reading. If we go back to the reading, they talk about quartz and its hardness, and they talk about mica and its softness. So right here, yes, the silicates are grouped into 6 classes based on the arrangement of tetrahedra. The tetrahedra is how it's like the scientific term for the pyramid. A tetrahedra is a pyramid, 4-sided. In their crystal structures, for example, quartz is representative of a silicate class in which tetrahedra are tightly packed and bonded together at all corners. And so if I come back over here, where's my PowerPoint? There it is. Let me go down to the next slide. There were buttons here. Let me just go down, I guess. And go down slowly. Did I go too far? Maybe I did. Maybe I didn't. It's going to show it here. This is a little bit advanced. That's not the greatest thing. So basically, that's not illustrating it the way I wanted to. You have these little pyramids. In quartz, they're all packed together where every single corner of that pyramid is connected to another corner of the pyramid. And so they tell you that in the reading, and I would just type in this sentence. Quartz is representative of a silicate class in which tetrahedra are tightly packed and bonded together at all corners. The tight arrangement makes quartz very hard mineral. And so those little pyramids are all connected in every single way, every single corner. They're bonded together. And so when I go to try to break quartz, I have to break through a whole bunch of bonds in order to get that quartz to break the way that I want it to. So I got to put a lot of energy in. That makes quartz very hard. If you go down to the very next paragraph here, they talk about the clay minerals. And you got to read through a little bit. But basically, in the clay minerals, instead of everything being bonded together, they're just bonded at 3 of the corners instead of all 4. And that makes this nice flat sheet. And so they're only bonded in kind of one direction. And what that gets you, and we'll read what I want you to kind of type in a second. If we go to the PowerPoint, what that gets you for biotite is, right, if I can go up, one more, right here, big screen, boom. This is biotite. It comes in kind of big chunks. You don't always see the thin sheets right away, but it comes in big chunks. And what you can do is you can take your knife and cut in between these thin sheets because there's not really very many bonds in between those sheets. So what it does, it peels off into this really thin sheet, which you can see is actually see-through. So it's almost like a thin film of plastic, but it's a rock. It came out of the ground. It's a mineral. So when you cut through these sheets, you get these really thin sheets here of biotite or muscovite, and that's what they're talking about. That's what your cleavage is. It separates it into flat planes. So if I come back, if I can end the show, and we go back to the reading, it tells you because they're only bonded at 3 corners and not every single corner, the micas, their sheets are very soft, which allows them to break very easily. And so that's what I would put. Your quartz is bonded at every single corner, and so that makes it very hard. Your biotites and muscovites are only loosely bonded together, and they're bonded at 3 corners, so that's going to make it a lot softer. And so you're really just using this paragraph and the paragraph right above it right here to answer those questions. And so that should be it. That should be all 3. Go back to the question. We identified the chemical class. It was silicates. We described the basic chemical unit for both quartz and mica. It was the SiO4 molecule. It's shaped like a pyramid, and the composition is 1 silicon and 4 oxygens. And then how does the chemical structure of quartz and mica affect the relative hardness? Quartz has bonds everywhere all over that pyramid, and they're all very strong, where mica only has bonds on 3 points of the pyramid, and some of them are relatively weak. And so that makes quartz much harder than mica because mica has a lot of bonds that are super easy to break. And so it's going to be easier to scratch or cut through mica where you can't really easily do it with quartz. So if you have any questions, let me know. If for some reason you're not doing it right now, the video will be posted online. Or if anybody's absent, I got a student in quarantine. So yeah, and that's it for today. Nice short assignment, and we will lecture over the next section tomorrow and start the actual first section of minerals. Thank you, everybody. Have a nice day.